So we'll dive right into chapter 12 concepts, which pretty foundational concept is chapter 12. Hopefully you got a chance to read it, but the topic, and why is the important topic? The topic is classes and objects. You know, what is a C# class? What is a C# object? And why is it important? Well, foundationally, it's a very simple answer to why classes and objects are important, which is this object-oriented paradigm, like object-oriented programming, is all this concept of code reusability. I can't tell you how many times in this industry you will hear that term of making code that's reusable. And so the whole reason, you know, when we kind of started learning methods, I said, look guys, you can write this method and you could call it 100 times. And so you're making your code reusable. Well, what is a method? A method is a behavior. It's an action. It's a series of steps. Well, an object is all about reusable code. We're going to make this thing that's reusable, and this object has methods. And so built into these objects or built into these classes, there are methods. Which again, you can write a method once and call it 1,000 times. But in addition to that, it's just a class. A class has methods, but it also has what are called attributes, which are just pieces of data. So in summary, you know, it's always important for me to talk about why this is important. Classes and objects are important because of code reusability. This allows us to not only write reusable behaviors like methods, but now we have reusable pieces of data. So we could say, we can define a thing, and all of our things have these important pieces of data. And so because we understand, you know, because we understand the object, by understanding the object, you understand the pieces of data that it has associated with it. Okay? So, try to say this more concisely. It's all about code reusability. Just like a method is reusable actions, objects have reusable actions and reusable attributes. And that's really what it is. An object is just a thing that has those reusable components. And so let's break that down and actually see what it looks like. Again, this happens to be chapter 12. So I believe the CH12 is going to be my solution name. And this will just be class demo. And let's just dive right into classes and objects. Again, I'm kind of doing a less traditional lecture here. I'm not even going off the PowerPoints. We're just gonna code, and I'm gonna talk about the components and solve some problems using classes and objects. So right away, we're still doing Windows Forms. The first thing I'll do is add this thing called a class. And right away, if you right-click the project and go to Add Class, you can go to Add New Item. And if you click Add New Item, you can select Class. But right from the quick menu here, there's this thing called a class. Right? This morning, we're interviewing an alumni. And I told Kevin, I said, hey, we're interviewing classes. We're discussing classes and objects today. So you know that a class is a fundamental component. It's pretty important. It's so important they have it on the quick menu, right? We create a class. So first off, what is a class? What is a class? Well, the textbook definition of a class is that a class is a blueprint of an object. If you think of what a blueprint is, like I think of an architectural blueprint, you know, when I was growing up in my neighborhood, a lot of our homes were designed the same way. And so I could go into my neighbor's house and roughly the kitchen was in the same spot. The bedrooms were in the same spot, right? Why was that? Because our homes were constructed from the same blueprint. Same thing happens in software. We make these software blueprints, and then we construct our objects out of them. Does that make sense? We're going to build the blueprints and then construct objects out of them. The blueprints are your classes. So a synonym for a class is a blueprint. A class is a blueprint. But a blueprint by itself is not a house. You have to build something using the blueprint. Okay? So it's a two-part process. Number one, create the blueprint. Number two, use the blueprint to create the thing. Okay? So, it's a two-part process, and not getting those things, are we creating the blueprint or are we using the blueprint to create the object? You got to understand there's two parts there. So number one, what is a class? A class is a blueprint of an object. What the heck is an object? The best way to think of this, a class can be any, listen to my words, a class can be anything. What is a thing? In the English language, we have something called a noun, right? Go back to your English class. What is a noun? A noun is a person, place, or thing. So a class, generally speaking, you take the real world thing, the real world noun, the person, the place, or the thing. The class is the blueprint for that thing. Okay? So in software architecture, right, which by the way, you can be a software architect. It is a full-time job. All you're doing is making blueprints. Right? In software architecture, you have a class. A class is a blueprint of a thing. So what's a real world thing? I don't know. You guys, we can make a class around a thing. Someone give me a thing. What thing should we create in our software?
Car.
A car. All right. Car.cs. So I like to think of it this way. We have a real world thing. This class is how we're going to create this thing in code. We're going to create this thing in code by making a class. So it's the software representation of a real world thing. And the thing that we have is a car. And so let's click add. And this is what we end up with. It's car.cs, and there's this keyword internal. Okay, and we'll talk about this. The word class and car. A couple things that are worth noting off the front. This car is capital C. You'll notice the file name is exactly the same. Okay, capital C-A-R, capital C-A-R. Okay, I anticipate that should not compile. In some languages, it doesn't. Okay, I can be wrong about that. Let's not do that. Okay, let's keep it like this. Okay, some languages are, I guess, more strict than others. Turns out that that's not the case in C#. They're actually, that's besides the point. The point that I want to make, very typically, that's just a rule that the class name has to match the file name exactly. Okay? I guess there's a little leniency. I'm just kind of curious here if this will still work. This is really surprising me. You learn something new every day. I would not expect this to work at all, but here it does. Let's not do that. That's bad practice. Let's stick to good practice. We'll just call this good practice. Okay? So, we now have a blueprint for an object. By creating this thing, this class is this thing. By creating this class called car, we are creating a blueprint for an object. By the way, this word internal, you can keep that internal. Very typically, it's common to mark these classes as public. So I'll go ahead and do that because that's what I'm used to. We'll talk about the difference between private, protected, internal, all this stuff, all these keywords. We will talk about their differences because they are important. But I'm going to mark my class as public. I said there's reusable methods. Classes have reusable methods and reusable attributes. The most important piece of anything IT related is always the data. The most important piece of anything IT related is always the data. All right, that's an important rule of thumb to remember. If there's one thing you remember today, remember that. The data is always the most important. You know, last couple of weeks we've been making these methods. What are these methods doing? They're sending data back and forth. They're manipulating the data, you know. But really we make these methods to work with the data, right? These computers ultimately work with data. The monitors display our data. The wires transfer the data. The databases hold the data, right? The most valuable asset in the world is data. It used to be oil. Oil used to be the most valuable asset in the world. It is now data. Data is more valuable than oil. It is the most valuable asset in the world. Data is really important. Data, where do we store data? We store data in attributes. Attributes simply, what are the attributes of a car? What are the things to our software that are important to store about the car? And then we're going to make some methods that work with the data, right? So in a class, there's, again, summary here, there's two things generically speaking. There's attributes and then there's methods. Attributes are just our data, and our data is always stored in variables. So we'll get into this, but ultimately we're just working with data, and data is stored in variables. Yes?
So if you wanted to say like the car is red, is red an attribute?
Yeah, so let's go there. Let's go there. Let's actually make an attribute of the car, right? So you would say, hey, if the car is red, you know, what would you name that attribute? Maybe car color, right? And because it's red or green or yellow, what data type would that be?
String.
So I'm going to say private string car color. Now, in the class, notice we're not implementing the class yet. We're not creating our car. This is just the blueprint. So am I going to say car color equals red here? Absolutely not. Later on, we'll define the car color, right? We're not creating the car right now. We're creating the blueprint for the car. So we're saying, hey, cars have a color. Every car should have a color, right? What other attributes might we have for a car?
Price.
Oh, that's a good one. So we'll say price. Private decimal car price. Anything else? I don't know. It doesn't matter. We can make this more complex or less complex.
Type of wheels or brand of car.
Brand. Let's just go with brand. I like brand. We'll say private string car brand. Okay, we'll just keep it at 3 for now, just to get started. Okay, it is common to have 20 attributes or 30 attributes or 40. Whatever the attributes that are important to your company, like what's the data that's important to your company for this software, right? You got to define those. And that's why, you know, in all these alumni meetings, there's a lot of meetings, right? There's a lot of meetings discussing with managers and they say stakeholders, right? The people that are using the software, what's the important data? Now I call these attributes a more technical term because attribute's a piece of data. A more technical term that's used, and you'll read this in the book, is this term called an instance field. Okay, this is a more technical definition than an attribute because this says something unique. This says that every instance of our car can have a unique color, price, and brand. Now they can be the same, like you can have multiple Teslas, right? So the car brand of multiple different cars can be the same, but they can also be unique, right? Every instance has its own unique data. And sometimes they match and sometimes they don't, but they have the opportunity to have unique data. Okay, so, but at the end of the day, these are just variables, right? Now, back up just a second. We've had variables so far. We've had local variables and parameters. Local variables and parameters, their scope is the method that they're in, right? And that's the scope. Now, if you notice where we're defining these at the class level, right? So these variables are kind of like our class level variables, but now our class is no longer a form. Like before, we were working in this class called form. Well, in C#, you make classes for all of your GUI components, right? So someone else coded this form class, and we're just using it, right? We're creating an instance of the form class. So point being is that these are kind of like your class variables, but you're going to notice there's a new thing. Our class variables before, like if we had we might have like int count, right? This is what we were doing before. There's a new thing about our instance fields that we mark them as private. Okay, and so there's a new keyword here called private that is an important keyword that basically says this, that these variables are only in scope inside of this class. In other words, you can only access them inside of the car. Okay, believe it or not, when we didn't do private here, you could have said private int count, and that would have worked. Okay, but as it turns out, the scope of count, because it's not marked as private, you could actually access this variable in other files because the default is more accessible than private. Okay, so there's some other access modifiers, things like internal. These access modifiers control the scope of the variable. And so private is the most secure access modifier. So I'm going to back up just a step. So what is the keyword private? Private is the access modifier, and it controls the scope of the variable. Remembering that scope determines what part of the program can access and work with the variable. Okay? Private is the most secure. It's the most locked down. It's private. It's saying only in this particular file can you work with these variables. That's actually considered, they call this data hiding, right? So in object-oriented programming, there's certain important concepts. Code reusability, you hear all the time. Data hiding is the concept of hiding your data within a class by marking the instance fields private. So you're kind of hiding the data from all other parts of the program. All right, so instance fields, these are just attributes, these are just pieces of data. You mark them private for security. Just consider it the security aspect of it. Yes?
Okay, so I mean, the car class is public, but the attributes inside of the instances are private.
That's
so
right.
Can you access the class from other places, but not those?
Not these variables.
Okay.
So the question is, can you access the class from other files but not the variables? The answer is yes. In fact, when we come over here, you can now notice we have a new data type. The data type, once you've got this file called car.cs and it's marked public, we can now create something called car. It's a data type. Right? So the identifier is my car. The data type is car. And this is creating an instance of the car class. You've seen this before, have you not? Random generator equals new random. Remember this? Remember this syntax? It's the exact same syntax. We're creating an object here. You created an object here. It just wasn't your own custom object. Now we're creating our own custom objects. Yes?
So you're saying my car is a data type, but wouldn't car just be a class? Like when you hover over it, just says class.
Yeah, it is.
So, but it's still considered a data type.
Well, isn't integer a data type?
Yeah.
So there's a good question. So there's the built-in data types, which are often called primitive data types. Integer, double, float. These are often called primitive data types because they've just been around forever. These data types that are classes, they're called reference data types. Remember passing by reference? There's a tie in there. Okay? But these are called reference. In other words, they're classes that are, they're objects, they're data types created from classes. Data types created from classes. Before we get back to this though, I'm going to hold off on this and kind of focus on the class. So we've got this concept of data hiding. The concept of data hiding is saying, hey, our instance fields should be private because our data is the most important piece. So we want to lock down the data. We want to make them private. And we want to control access to this data through methods. So with the methods, we can manipulate the data, but you cannot directly manipulate these variables. You're only going to be able to manipulate these variables through methods. Okay? What does that really do for you? That allows controlled access to what goes into these variables. You can control the data that goes into these. Data hiding makes our data private because data is important, and you control what goes into the variables and what comes out of them really through their methods. So the second part of this is with data hiding, we can manipulate and access our data with public methods. So the data is private, and we're only going to allow access to our variables through our methods. In other words, car color, Josh, you said, hey, I can't access car color over here. You notice if let's just go into like this little method here, and I say my car dot, there's no car color here. Car color is a private variable inside of that class. So what do we actually have here? We actually have some methods that we get for free. We'll talk about these methods and like how they're used and whatever. But for right now, they're not super important. Okay, the point is that you cannot set your car color here. You really can't do anything with my car yet. Okay, so what do we typically do is we make public methods to do two things: manipulate and access It's just a piece of data. What do you need to do? You need to give it a value. You need to change it. Right? You need to maybe initialize it with some data, give it some values, and then later on you need to read it. So you need to write to it, you need to read to it. Like those are your operations, read and write. So the read and write operations, that's what we're talking about with our methods. And so these methods are often called getters and setters. Setters are going to be your write operation, getters are going to be your retrieval. And so I'll just use a getter and setter on car color. So let's make a public method. I said here that public methods, our instance fields are private, our methods are public. Our public methods, what comes next? The return data type. Now I'm actually not going to return any data here. All I'm going to do is I'm going to have one parameter that allows them to set the value, and I'm going to assign car color equal to the value that's passed in. So I'll do set car color. This is a method called a mutator. It's going to modify the car's color. It's a mutator that's going to modify the car color. I even put a mutator, you could also call it a setter. Right, I think they call it getters and setters, or they call it mutators and accessors. Same kind of stuff. This is really traditional OOP stuff. This is really, they've been doing this since the 90s. This is not new. Okay? So we've got an instance field. Our instance field is private. By the way, in this class, I'll even mark this. It is a convention to mark your instance fields with underscores. So when you see an underscore and then a variable, you know that's an instance field. Because an instance field is different than a local variable. It's different than a parameter. Okay, this method is going to allow for the input of one piece of data. And you can kind of see here the syntax of underscore car color equals the car color that's passed in. So what is this method doing? All this method is doing is assigning a value to car color. Can everyone see that, right? I highlight car color, underscore car color. It's just putting data in. That's all we're doing here. And I said that, hey, these mutators can control access to the data. I said that's the advantage of data hiding. Everyone remember I said that, right? So what can I do here? I could say, well, if the parameter car color is null, give the user an error message. How about if string dot is null or empty car color, then we give them an error message. Else, we're going to go ahead and set the values. Missing a. This if-else statement is controlling access to the data. We're not allowing an empty or a null value to be set for our car color. Just as a simple example. Okay, there's many examples of this. If the salary is outside of a range, if the number is too high, if the number is too low, if the data is no good, all these kinds of things. Yes?
So would you be calling set car color from like a different class?
That's right.
Area?
That's right. So here we've created a car. And maybe we ask the user for a car color. So for now, we're just going car color. We create the car. I'm going to create my car object here. And then say my car dot set car color. Does everyone see that method, right? This is a public method that's now accessible. Now I can set the car color to be whatever inside of the text box, text car color dot text. This is a string. This method accepts a string. Do you see why we covered methods before this? Right? We had to understand that, hey, this is a method. This method accepts a string. Here, it checks for an error message. You know, checks to make sure it's not empty. Otherwise, we set the car color, underscore car color. So that puts data in. This is how we put data into the field now. So how do we pull data out? So all I'm going to do is now I'm going to pull data out. So this is a mutator or a setter. These are basically two terms that mean the same thing, to put data in. Vinny, you had a question?
Yeah, I was just going to ask, like, so with the whole, where you're passing it a string car color, where is that string coming from?
It's coming from the text box right here.
Okay, so that's how you, okay.
So this method takes in a string. I passed in the text property of the text box.
And it's storing it in a variable called car color?
Yeah, underscore car color. So let's follow this. I'm going to put a breakpoint in here. Red is in the text property of the text box, right? So car color, without the underscore, the value comes in as red. Well, this if statement should be false because it's not null or empty, it's red. So now we're setting the instance field equal to red. The instance field of underscore car color is equal to the parameter that was passed into the method. So as of right now, I have not executed line 41. You can see underscore car color is null. So for that car, for my car color is null until this line executes. As soon as I execute this line, you can see underscore car color for my car is now red. So now I've set the car color. I've put data in, but now I got to pull data out. So this is a, let's label this. Create an instance of the car class. By the way, that's called creating an object from the car class. Anytime you see the keyword new, you're creating an object. Calls a mutator method to set the instance field value. The instance field is underscore car color. So we're going to use this public method to modify the private data. We use public methods to modify private fields.
And so you're storing your data in the class of car?
You're storing it in the field that is a part of the car class. Ultimately, it's being stored in underscore car color.
But even though you're not like actually coding out that this is like an object, it's just kind of getting stored there as new car. And I guess my car is okay.
Yeah, so you are creating the object right here on line 28. So line 28 creates the object, and then line 31 sets the color. So what do we, we're creating this thing. This thing is a car, and line 31 sets the car color.
So where does it get stored? Like, where does the information get stored?
Ultimately, it gets stored in underscore car color.
Okay.
Because here's where we set car color equal to the data that's passed into the method. We could call this different. It doesn't have to be car color equals car color, but it does make sense because that's what it is. It's just sending data around. Ultimately, where does the data start? The data starts in this text box, in the text property of a text box. It then gets sent into this method. It comes into this port right here, into this method, and then here we set the instance field. Like really, it's all about these instance fields. It's all about these instance fields. It's all about the data. The data is the most important piece, and this is where the data is ultimately getting stored.
Okay.
Vinny?
So what's like significant about this that you couldn't just do by doing like, string underscore car color equals txt blah 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 in that text?
Well, now we have this reusable thing that's a car that has reusable attributes and reusable methods. So what's significant? Why couldn't we just store a string car color? We now have this coding structure that is just completely reusable. And again, it really boils down to code reusability.
So it's like, you can create a bunch of different cars.
You can create 1,000 cars, and they all have the same. The 1,000 cars all have the same attributes and the same methods. And so we'll do that. We can very quickly create 1,000 cars. So the last thing that's left is very quickly, let's create a method to get the car data. So if this is our mutator, let's do public string get car color. And this is just going to return underscore car color. Remember the last method put that data into the field? This method is just going to return that field. So the return data type is string, and we're going to return the field that we're going to get.
It's a setter.
The setter, and this is the getter.
Oh, that's it.
Yeah, the setter, getter, setters and getters, also called mutators and accessors. This is a mutator. That's you're mutating the data, you're changing it, and you're accessing the data. And so back here we modify the data. Now we're going to read the data. And the way we'll do that is we'll put it into a label. Just call it label result. Label result dot text equals my car dot, if I type get car color, there it is. Vinny, I think you mentioned this before. It's like on the surface, it seems like a lot more work to do the same task, right?
But then when you do it in bulk, it's like.
But when you do it in bulk, that's where you see the efficiencies. It's hard to do it right now in bulk because we're just learning this stuff. We can't do anything in bulk right now. We will very soon, but we can't start there, right? We can't start in bulk. So what did we do? We created a car object. We had an attribute. We said the car is red. We put data in and we pulled data out. That's all that we've done. Let's go back to here. I'm going to get rid of my notes. It's all recording. If you're that concerned with my notes, go back to the recording. This is so common to have instance fields, and then every instance field can have a mutator and then an accessor. So let's make our next instance let's make our next mutator for car price. So this is a mutator for the color. I'll say public void set car price, decimal price, underscore car price equals price. Take a look at my code real quick. Break it down in your mind. What are the different pieces? Public means access modifier. The parts of the program that can work with this method is pretty public. It's kind of wide open. If you create a car object, you can set that car's price. Access modifier, void, that's a return data type. We're not returning anything to this method. We're just setting a field. That's all we're doing, is we're setting a field value. Set car price is your identifier. Decimal price, that's your parameter. So, assumingly, that's your input to the method. The price is going to come into the method. What does this line do? This sets the field underscore car price equal to the value that's passed in to the parameter. Remember, public methods control access to private fields. Public methods control access to private fields. I could say, look, if the parameter price is less than 10,000, we don't sell those cars. We only sell expensive cars. So we don't put the data in. You know, AKA maybe give them an error message. Else, now I could get input from the user, right? I could get it from a text box, but let's just do this. My car dot set car price, and you can see our public method accepts a decimal price. So let's just say 15123M for decimal. So a $15,000 car is accepted, but I don't have the other half of the equation. The mutator puts data in, the accessor pulls data out. So if I have set car price, I need to write a getter. Public decimal is the return data type. Get car price. Notice this one has no parameters. Return underscore car price. And we're just sending the data back. We're sending the data back to the calling method. So here we said my car get car color. My car dot get car price. You know, this is going to be really ugly because it's going to print them together. So if I say red 1500, how would I format that better? Huh?
You could add like a break or a space.
Yeah, just add some spaces. We could do like, remember this kind of stuff. We could do the car objects, the car's color is my car dot get color and the price is my car dot get car price.
So why do we hard code 1500 or 15,000?
Well, we could have had another text box, right? You could have had a text box asking the user for the car price, but let's just say we're the dealers. We're going to set the price, right? Notice what happens. Remember here I said, hey, if the price is too small. Didn't I do that? Let's do that. Let's say if, nope, that's the wrong spot. Right here in the mutator, I said if the price is less than 10,000, I'll set the car price equals, I don't know, we're just gonna code in, if you try and set the price too small, we're gonna set it to be really big. Right? Just making something up. This is completely fictitious, right? But the idea is if the user tries to get, like, they're trying to scam the system and set the car price to $1,000, our if else is going to run, and it's going to set the price to 20K. Controlling access to the private variables. We controlled access to the private variables in our mutator by having some business logic that said in our business, we don't sell cars that cheap. And if any coder tries to scam the system or something, if anyone tries to get around our business logic, we're just not going to allow it. So a lot of times what happens is you say, well, Mr. G, couldn't someone just come into here and change the car class and just change those numbers? Well, you don't always have access to change other people's classes. You might have access to your classes that you've worked with. But notice, like, for example, like back here, remember I started like talking about the random class? We don't have access to go into that class and start changing their source code, right? So there's people who create the classes, and then there's consumers of the class. And so sometimes you can only consume a class. You're not always creating the class. So if you're creating this class and you have access to the source code, you can write business logic that other people can't change. See a couple people shaking their head like, okay, it's starting to make some sense. Let's just make this one. Remember, this is called data hiding. Remember, this is called data hiding when we make these instance fields private. I'm going to change this up and I want to show you guys something. I'm going to set public to car brand. So now this field is public. Remember before we were using public methods to work with our fields. But now this is bad. This is bad practice. You do not do this. Because what this allows you to do now is I can go my car dot, because this is public, I should have underscore car brand. I have direct access to the field. Because I have direct access to the field, I can put whatever I want in here. It's a string. I can put whatever I want. There's no controlled access to the data. So I could say, maybe we don't sell, I don't know, whatever. Maybe we don't sell Teslas. But because whoever is the consumer of this class has direct access to the field, they can put whatever they want into it. There's no controlled access here. Right? So we do not do this. We do not mark our fields public. Our fields are private and controlled through public methods. And because let's take this back to private, and let's do this a third time. Let's have a mutator public void set car brand string brand. By the way, when I learned this, do you see the pattern? Do you see the pattern for these mutators? These mutators pattern, I memorized the pattern. The pattern was mutators are void return types. They start with the word set. They take one parameter, right? I memorized the pattern is how I learned to write these at first. My accessors have a pattern too. The data type that they return is the same data type as the field they're working with. So this color is a field that's a car color, so the return data type matches the field that they're working with. There's no parameters here. And all they typically do is have a return and then the field. The field is just the variable up at the top. So for people who are learning this for the first time, recognizing this pattern for these methods and recognizing the pattern for these methods is how I got by. I literally just memorized the pattern. And so if I write this third one here, set car brand, what does this one look like? Underscore car brand equals brand. And here I could write some logic. If brand contains the word Tesla. Now, what about this? If brand to lower, right? If the brand to lower contains the word Tesla, not here, buddy. Else, we accept all other brands. Now, I love Tesla, but that's just for the demo, right?
You have one?
I wish I had one. I'm also a cheapskate, and so they're not in my price range. Someday. If brand too lower, the way gas prices are today, we might all be electric before we know it.
When I test drove the Model Y Performance, and it was pretty nice.
Oh, I can't imagine. That's
Just like the thing about electrical, just
okay. So again, controlled access to our variables here, right? Controlled access to our variables. If they try and set the brand as Tesla, we're going to set the car brand to Kia, right? We're just not going to allow it. And again, probably really what you're going to do is just give an error message to the user, like, just turns out we don't sell those, you know. But in my code example, I'm doing this. So car brand. So again, what would we really do? Well, now this no longer works. We just can't set car brand this way, but we can call the mutator set car brand, and it's a method, so it goes in like this. Methods have parentheses, right? So my car, set car brand to Tesla, this should actually come out as a Kia, right? Because we're not allowing it. And the brand is mycar.getCar. Uh-oh, we didn't write the accessor, right? So let's go back. By the way, look at the notation, right? Object name dot method name. Object name dot method name. So let's write the accessor, public string get car brand. Return the field called car brand. And again, I try and set the thing here. It's not going to allow it, but we'll do mycar dot get car brand. Bada bing, bada boom. And again, we're setting the color with the text box, but everything else, the car's color is green, the price is $20K, and the brand is Kia. Now, anything else it would accept, right? So if I said Cadillac, which by the way, make and model, these are different things. I realize brand, Cadillac is actually GM, right? Wouldn't you say General Motors?
Yep. I guess that's the parent company, but that each brand is like a.
Oh, so you're right. Cadillac would be the brand.
Yeah.
The parent company is General Motors.
Yeah, I mean,
So we're getting into the weeds, but it's, I like being accurate. There you go. Cadillac is accepted. Now here, let's code reusability, right? We've got this car. This car has fields and methods. Let's create another car. Your car is a new car. And now I can do your car dot set car color purple, and your car dot set car price, and I think the lowest price was 10,000, maybe. What was our price? Whatever. We're gonna set your car's color, your car's price, your car dot set car brand. I literally heard today someone was telling me about their Pinto. That's like the just, you know you're old, right, if you drive a Pinto.
I think they were still on the road.
Well, this is, yeah. I don't know, was it a car of the 70s, 80s? I don't know.
That's right.
So now we have two cars. We got my car and we have your car. This is the blueprint, the car class. We can use that blueprint to create two car objects. We load the data, and now I'll append the label result plus equals, and I'll just do your car color, your car get color, your car get price, your car dot get brand. It's a lot faster to create your second car, isn't it? A lot faster to create your second car. The only input is on my car color. Okay, a couple things here. Let's put in a line break \n here, so we can have a line break between the two cars. It's also kind of a fun little property here. You might have wondered this. Maybe you found this, maybe you haven't. If you highlight the label, you could set auto size to false, and then you could just kind of say, look, I want this label to be in this box. So it's not going to wrap or do whatever it was doing, not wrap. There we go. So now my car's color is red, the price is 20, and the brand is Cadillac, the car's color is Pinto, the price is 10, and purple, 10, and Pinto.
There's a nice Pinto in the thing.
That's right. That's right. In fact, what if there were 100 cars? Car used car lot equals let's create an array of cars. Now we have an array of cars, 1,000 cars. We're going to have to write some sort of logic, some sort of loop to put in a bunch of data into these cars. Ryan?
And then couldn't you technically put in for all of the attributes of the car? Could you make random classes and then have it just loop through a bunch of presets?
Yeah, so where can you get the data? You could hard code the data. You could generate some random data using random number generators and that kind of stuff. Last semester we used a fun little tool called, remember that website?
Oh yeah, where it creates all of the JSON.
That's right.
Stuff.
So there are websites that can generate dummy data for you. It's not ringing a bell. But I'm just going to show you how it could be done quickly. Okay, I'm just going to make up the dumbest dummy data that I can think of. Okay, so let's go ahead and make a for loop that'll loop through used car lot.length. When you have an array of objects, this actually creates the array, but you also have to instantiate each individual object. So what is this? This is creating an instance of a class. So when I say you have to instantiate each object, that's what I'm doing here. You're instantiating an object. You're creating an instance of a class. This line right here, new car, is when you actually create the instance. This line right here creates the instance. Notice I have not created the instance on any of these cars. So here's what I'll do. I'll say used car lot sub I equals new car. This instantiates my first car. Well, actually, how many cars does this instantiate? That's instantiating 1,000 cars if you go through the loop. This will be used car lot sub 0, used car lot sub 1, sub 2, sub 3, sub 4. We just created 1,000 cars. We created an array, and we instantiated all those cars. So then let's say used car lot sub I dot set car color. We're going to make all of our cars red. Used car lot sub I set car brand. We just bought a bunch of red Kias. Used car lot sub I set car price, and they're all 25,000. Now, you know, in a used car lot, you're probably going to have, this is really dummy data. But the question is, how do you go about putting it in? Well, you could use a loop. The important thing here, the important thing on this to note here, is that when you have an array of objects, there's actually two important parts. This line, line 30, creates the array. Line 34 creates the object. And then what can you do? Well, let's just you can grab one of these at a time. Let's take this out. And now this will be used car lot sub, I don't know, 0. Used car lot sub 0. Get car price. And used car lot sub 0. Get car brand. Right? So we got 1,000 cars. I'm just reading one car's worth of information. I just want to put the data in and pull the data out just to show you it doesn't really matter. Red 25 and it's a Kia. So all of our cars, it doesn't matter if it's the first car at position 0 or the 6th car at position 5, they're all the same car. I'm going to pause the lecture right here. We'll take a break, and then I'm going to come back. We're going to do more practice. Okay, that's what today is. We're just getting familiar with these concepts, so we're going to do more practice. Zoom. Let's just follow along and ask questions. You don't have to code. Just follow my demo. For this, I'm going to create a class called Hockey Player. I'm going to make it public. And the instance fields are going to be player name, goals scored. I'm going to write some mutators to put the data in.
Wait, so if you're adding a new class, you don't have to make a whole new solution. You just do add new class.
Yeah. Yeah, so I just right click, add new class. Now I made a new solution, or I made a new project.
Oh, okay.
And in this one, I've got my hockey player, and in this one, I've got my car. But I could have hockey player class and another class called coach, and you could have multiple classes in the same project. So we'll make our mutator to set the goals scored. Actually, what we'll do is we'll say public void we'll make a way so that we can increase the goals by 1. Right? So every time they score a goal, we call this method that increases the goals. So we'll say goal scored. And goal scored just increases goals scored by 1. Right? So this mutator just makes it go up by 1. But then we can also have one to set public void set goal scored, and we just got GS. Goal scored equals GS. By the way, I just showing you the instance field equals this. GS is a bad. Better off just calling it goal scored. Like, what is it? Don't abbreviate. Spell it out. Instance field equals that. So we have a way to not only set it initialize our data, but also increase it by 1. So then we'll say public void set player name, string name. Okay, so we set the name, set the goal scored, collapse those. Public string get player name. Return player name. By the way, you'll see this arrow syntax. This is a condensed version.
Is that returning player name?
It returns player name. Right? So I'll compare the two, right? So I'll say public int get right? So this is the non-arrow syntax. This is the arrow syntax. As we continue to learn, as we continue to discuss this, I'm just going to keep referring to it's all about these fields. What are these methods doing? They are putting data in, they're modifying the data, they're pulling data out. I'll even say increase goals scored. Increase goals scored, and it just goes up by 1. Question?
Yeah, I'll save it for later though.
Okay. So now for this demonstration, I'll just put everything on a button click. Say create players. Create an individual hockey player called, who's your favorite hockey player? Anyone a hockey fan?
Tarasenko.
Oh boy, Terass.
I have no idea actually.
T-A-R-A.
Tara, yeah.
S-E-N-K-O.
Sure, Tarasenko.
There you go.
All right, we created Tarasenko. Tarasenko.set. Now, this is just the identifier, but that does not that's not actually setting the field, so that might be confusing. Calling your object Tarasenko does not set the player name. To set the player name, so we'll just call this, Blues player, just call it Blues player, whatever. So then you say Blues player dot set player name. I'm sure I'm butchering it, but you get the idea. Blues player dot set the goal scored to 100. And then we could just say Blues player, he scored another goal. So increase goals scored. So, takes his goal scored from 100 to 101. And then we'll have an output label. Then we'll take it another layer deep. It's called label result. Label result.text equals blues player dot get player name. It's a method. So that'll say Tarasenko has scored this many goals this season. And this many would be blues player dot get goals scored. Puts a little concatenation, string concatenation going on there. Creating an instance of the object, putting data into our fields, manipulate, this puts some initial data in, and this modifies it up by 1. So this will say Tarasenko 101 goals. Check it out. Let's run the right program. I did that one fast. Questions about this?
Okay. My question is, how do you set a new class? Because I'm not seeing that, add class.
Yeah, so to create that new class, you right-click the project,
Okay.
then go to Add Class.
Add class.
It's also under this New Item menu. So if you click New Item, there's a class up there at the top.
Okay, yeah, I did it wrong. Okay, and then you set the name before you click add.
Yeah.
On that one, okay.
Yep. Now, I said create players, and here I just created a single player. So let's comment this out for now. Not that line. Let's comment this out for now. Let's make a list of hockey players called the Blues equals new list of hockey players. I'm going to say blues.add a new hockey player. So this will be the first one in the list. And I don't have my shorthand syntax here. So to set the player name at this point, you would say blues sub 0 dot set player name. Kind of like when I was doing an array before, but in this case we're just doing a list. Right, so let's create a list of hockey players. Add one hockey player, give that first hockey player some data, and now let's pull it out. When we pull it out, instead of an individual identifier, now we have a list called Blues. So this will be Blues sub 0, get player name, Blues sub 0, get goal scored. Right, so if I play that out, works the same way, but now we're just, instead of having a single object, now we have a list of objects. Yes?
So could you do this to create a library of blues players?
Yeah.
Let's say you wanted to have a search, a movie database.
We're getting there.
Sports
We're getting there. We're getting there. Just to continue this, to add the next one, blues dot add a new hockey player. So this is our second hockey player, right? Blues sub 1 set player name, and probably, we probably can use some loops and this kind of stuff. I'm hard coding it at first. I've been to a few Blues games this season, and I'm ashamed to say I don't really care about. No shame. Who's their goalie? Tarasenko's their goalie.
I just know one guy's name.
Here, let's look it up.
Hold on, Google. Oh, okay, I should know Ryan O'Reilly. So he's a big name. I like this fella. What I like about this fella, he was the All-Star. He was the championship team's MVP. So he was the most valuable player when they won the Cup in 2019. I also, he's also a vegan, and I'm kind of on that train, so we'll go with that. I like him. Okay.
He makes 6.2 million.
He makes what?
6.2 million. That's a lot.
It's a lot, but probably not as compared to their counterparts in other sports.
Close.
Blues sub 1 dot set goals scored. We're going to give him 102, right? So there you go. So putting data into the Blues player, that's the second object in the list, and just changing the subscript at this point to get the goals scored plus equals, and then put in a line break, just something to make it readable. Okay, there we go. So now we have a list of objects. And, you say, hey, what if we want to search? Now we've got a library of Blues players. We can put the whole team in, right? We can now put the whole team. And we want to have a search button to see, because we don't know our Blues players like we should, right? So I'm going to say this is our search button. And I aligned the text to the right, but that's fine. And so now this is a button search. So this will create the players. This button click creates the players. This will search the players. Now, our list has to be more accessible, right? We can't have this list just in our button click. Let's make this list accessible to the whole form. So now our list is accessible. We create the players. That puts the data in. And let's allow the user to search with the text box for a last name. Or for players with goals over a certain number. So how about that? We want to search for the good players by searching for their goals. Right? So I'm going to search for the good players. So I'll say goal search with a label. Enter number of goals to search for. You get the idea. So we're going to say, okay, they're going to put in the number 50. We're going to click search. We're going to loop through our list. Blues dot. Remember the difference between capacity and count? Count is the number of things in there. Capacity is always probably more than your count. Like it has a capacity of 4, and then it doubles to 8, and then it doubles to 16. So we're going to loop through the count. Say if this is our text box 1, we'll call this text goals. Int search goal quantity equals int.parse txt goals.text. So we read from the text box, store it in an int. Right? This is the number of goals that we're searching for, called search goal quantity. We're looping through our list of blues players. If blues sub I dot get goals scored is a method is greater than search goal quantity label result dot text plus equals blues sub I, because this is in a loop, blues sub I has scored that many goals. And so we're appending to the list. And so right now they basically both have, I think one has 101, one has 102. So let's make this a little more realistic, 5 and 20. Okay, so Tarasenko has 5 goals, O'Reilly has 20. We're going to have to create our data, right? We're going to have to click this button first, and then we can search for goals that are more than whatever the user puts in. So if I run this, and I didn't make a mistake, let's create the players. That gives you some output. So Tarasenko has 6 goals, O'Reilly has 20. If I search for more than 10, that's a bug, but it says O'Reilly has scored 20 goals. So our bug is we need to clear the label result. Label result.text is cleared. Right, so we're going to clear that out. Debug, start without debugging. Create the players. Players are created. More than 10 goals is just O'Reilly. If I search more than 1 goal, you get both Tarasenko and O'Reilly. I see some squinty eyes. What's up?
So if you don't create the players first and just try to search for the goals, like what happens?
If you don't create the players first, you're going to get this thing to crash. Why did that not crash? It didn't crash because objects have default values. As it turns out, like our blues players, all of their names are null and all of their goals scored is 0. So it didn't crash because all of our data is null and 0. But basically what happens is you're doing a search against null and 0. So let's just put in a breakpoint. Debug, start debugging. Basically our count is going to be 0. So if I say 3, let's check out blues.count. Blues.count is 0. So what happens is we get our search goal quantity, which is 3, and we say, okay, I to 0 is 0 less than 0. No, it's not. 0 is not less than 0, so it ended our for loop. That's why it didn't crash, because our for loop never even processed any of the data. Does that make sense? Does it really make sense, or are you just shaking your head?
Yeah.
Okay, we're going to take this to another level. We're just going to keep going.
We're going into limbo.
Just keep going into the fog, man. Just keep going into the fog.
Going into the deeper level.
I gotta think about where I want to take this next. Okay, I mentioned when everything was paused that these methods called accessors and mutators. These are the traditional old school way of modifying our fields. C# has a newer tool that Java does not have. And so I wanted to show you these because some languages only have this tool, such as Java. And Java is still a really popular language. And so Java does not have the newer tool that C# has, right, that I'm going to show you. They can work together to do the same kind of thing, or sometimes you use one or the other. You don't necessarily need them both. And what those things are, right, are called properties. And so properties do the same thing as the mutators and accessors in a more condensed syntax. So let me show you a property, okay? And boy, the syntax, they really can get it short, okay? I don't want to show it to you all right out front. So public is our access modifier. Return data type is string. We'll just call this player name. This is the syntax for a property. This does the job of a mutator and an accessor, all stored in one thing called player name. Notice there's no parentheses, like a method always has parentheses. Properties don't have the parentheses. And they've got two blocks inside of them. Typically, you're going to see both blocks, not always though. Sometimes you can have one or the other, right? For example, if you only have a set block, the set does the mutator, the get does the accessor. And you can see here, underscore player name equals value. Value is a key word that represents the data passed into the property. It's a keyword that's going to hold the data passed into the property. So it's just a keyword here. It's always going to be value here. And then return the instance field of player name. Question? Yeah.
How is player name connected to underscore player name?
It is right, just because you connected it inside of these curly braces.
Okay, and then another question: why is get before set?
It could be the other way around.
Oh, I was just wondering if there was a reason. Okay.
It actually.
You want to set the value before you return the.
Yeah, this is the blueprint, so you can code them in either order, actually.
Okay.
Yeah, but I know what you're saying. Like, you would think that you would set it before you would get it.
But it's doing two different things because you'll be calling
That's right.
get or set separately.
So how do we use this property right now? Zero references, right? We don't have this property. We're not using this property right now. We're using the mutators and the accessors. So let's go back over here. Let's do blues.add new hockey player. Just like before. Blues sub2 dot, now we've got this thing called player name. It's got a different symbol here. It's a wrench. And you can see that this player name has a get and a set block. If you use it in this syntax, give me another blues player, Google. Oh yeah, Kairu, he was pretty good. I saw him. Kairu. I think he was an all-star. The methods we were using before had parentheses. This, when you assign a value to a property, first off, there's no parentheses. And you just put the string data right into it. Because this property understands it's working with a string, it sets underscore player name equal to Kairu. So it comes into value as Kairu. So underscore player name is set to that string. So when you code it with an assignment operator, it knows to call the set block. So by putting this equal sign right here, you're automatically calling the set block of that property. Let's do another one. Public int goal scored. Set goal scored is equals value. Get return goal scored. Actually, I want to finish this out because I didn't call the get block. So here when I'm creating players, let's do blues sub 2 dot, now I've got this goal scored property. It's a wrench. He's really good, so he's going to be we're going to say he's got the most goals scored. To get the data out, we're no longer using the accessors, we're using the properties. You would just say player name, blue sub 2 dot goal scored. Does the same thing, it's just working with this thing called a property instead of a method. Okay, Java doesn't have these. For whatever that's worth, probably not much if you're never caring about Java, but the point is, this is a newer feature to C#, and it allows you to do the same thing as accessors and mutators. If I debug this, run it, I create my players, you could see it worked just the same way. Kairu scored 25 goals this season. Put data in, pull data out. Put in my line break. Let's go back and inspect it and ask questions. So player name is a property that I created. There's no parentheses, right? Remember, these all have parentheses and parameters. We don't even have to worry about that here. We just said underscore player name equals value. That's a keyword. That's kind of like the magic, if you will. It's just something that you get for free. It's just value equals whatever is sent in right here. This is value. Kairu is value. So over here you set underscore player name equal to Kairu.
Well, and you can do like your if statements of like validating and all that.
You could still do your if statements to validate the data.
Mm-hmm.
Absolutely. You would say if value, so you could say if string dot is null or empty value, error message, else player name equals value. Let's see, I'm missing a curly right here. So this is all inside of a set block.
Oh, I see. Okay.
See that?
Value is what's coming into it initially.
Value is what's coming in initially. And so you test that value.
Mm-hmm. Cool.
And I know there's an arrow syntax here. I believe there's an arrow syntax. I gotta remember that. We'll keep that out for now. There's a condensed syntax. Now, last thing and then we're done, because we've been going on for a while. Properties work with instance fields. Accessors and mutators work with instance fields. You're always coding these instance fields private. There's something that's really common in C# where you create these properties in an even more condensed syntax than this. But the important thing to remember, when you use this new syntax that I'm about to teach you, you do not manually code these instance fields. The instance fields come along for free. You do not have to manually code them. So this new syntax, these properties are using these instance fields. There's an even more condensed syntax where you don't code these anymore. And in fact, coding them, and students get messed up when they still try to code these instance fields. And all of a sudden things aren't working, and that's because you get them for free. And so here's the syntax. I'm going to make another property, and I don't know, salary. Here's kind of the fun keyboard hotkey. If you type in the word prop, you can see there's a code snippet. Right? You guys remember code snippets? If you hit prop tab tab, this is the condensed syntax that I'm talking about. So let's just say the data type of this property is decimal, and we'll just call this salary. This is something called an auto-implemented property. What's auto-implemented, what's automatically created for you is the instance field. You do not need to make a salary underscore salary up here. But this basically makes a private instance field that's accessible through a public property that's just you don't need any extra control. There's no if-else statement like we have here. If you need control over the data, you cannot work with these auto-implemented fields. If you need if-else statements and loops and things like that to control, but if it's just a piece of data and you don't need to control access to it, you can make this thing called a auto-implemented property, and you could do it really quick. And so I can kind of come back over here, and now all of my blues can have a salary. I could say blues sub2 dot salary equals, and it's expecting some sort of big number here that can be converted into a decimal. So now I've got this property. It's just shorthand for salary. Vinny?
How come you're not having to put like M to convert it, or is it automatically being converted?
It's automatically converting the integer into a decimal. It's one of those widening conversions.
Where is it doing that?
Where is the question? It's happening right on line 39.
Okay.
Yeah. So that's how you put data into, and for example, since Cairo is the only one with that one, I'll say, and has a salary of blues sub2 dot salary. So this will be that he'll be the only one showing his salary when I create my blues players.
So it kind of automatically knows when to set and when to get, right?
Yeah, if you put an equal sign, it's going to call the set. If you don't put the equal sign and you just have it like this, it's going to be a get. There's more. I know you're excited. But I'm going to stop here for today because it's been a long day. So we'll stop the recording.